All right. Oh, good. Good. The mic is on. That would have been embarrassing. Yep. Everything seems to be up. Hello. Hello, everybody. Hope you're all doing well. Let me just get a few things sorted off screen. Definitely not filling here. Just normal conversation. Normal conversation that a human being would make goes in here. That's what I'm looking for. So yes, this is a stream where mostly we just fix ScummVM, which is a modern engine for playing old games, usually narrative-driven or adventure games, and more specifically, what we're working on is the Macromedia director engine, it was quite a very popular multimedia framework from the mid to late 90s with thousands of apps that don't really run that well on modern systems, which is why we're trying to get it running in our friend ScummVM. Last couple of sessions, we've mostly been focusing on this kind of strange mist-like Eastern Mind, The Lost Souls of Tongno by Osamu Sato. That stream is available in the archive if you missed it. And the upshot is we have a whole lot of things that we found wrong with that game. To be fair, though, when we were looking through it originally, there were a lot of, I guess, just, shall we say, strange design decisions which looked like graphical glitches. No, those are fine. We verified that on real hardware, and those are intentional. However, there are definitely some things which are a bit off with how we currently deal with Eastern Mind. So to that end, today I think we're going to try and focus on a couple of the bugs which are going to target as many of these as possible. The two that I was thinking of was basically there was one bug where I guess there were a few different screens which relied on palette swapping effects. So we'll try and look into that. And another one was that transparency didn't seem to be working very well. There was a lot of bits of the game which had blue boxes where there should really just be nice, transparent, I guess, mask. But yeah, lots of blue boxes everywhere, which should very well be transparent. So I think let's talk a little bit about the first one. Okay, so so helpfully we've written down the name of all of the movies that contain the issue. So I should have that Tree of Life one somewhere on here. Maybe I should just search for the words Tree of Life rather than just scrolling around. Yes, Rebirth Tree of Life should be pulsing purple. We've all had that problem at one stage or another. And also, how very odd. I would have thought, yeah, Trello normally has a feature where you can drag cards, but not today. Today, cards are not draggable. And that'll be because I'm not logged in. Excuse me one sec. Let me just move that over here. Yeah, so we'll talk a little bit about this. So if you're not aware, palette effects were a very kind of popular way in the olden days of computing to do, I guess, fancy visual effects quite cheaply. Nowadays we just kind of take for granted that all of the colors on the screen are RGB, which then means you get 24-bit color depth and other nice things. Back in the day, memory was expensive, especially the memory that was in your graphics card. And so in order to kind of save as much of that memory as possible, your frame buffer generally had some kind of palette scheme going on. And yeah, the one that is probably most familiar to a lot of people is 256 color mode. That basically just means that each pixel of your image is 1 byte, which contains a number from 0 to 255. And while that kind of doesn't sound like it would be, compared to a RGBA image, you're saving 4 times the raw buffer space for that. So that's not nothing, especially when megabytes of memory were some of the most expensive items in your BOM. Excuse me for a moment. I just drew a blank on Yes. So, that's right. Palette graphics. Used pretty much everywhere, and especially used in Eastern Mind. I will just... Oh, I've got DOSBox open. That'll help. Give me a moment while I switch over to DOSBox mode. Why can't I see DOSBox on that list? Ah, I can. I think. I thought I could, but it's not sure. Okay, this version of DOSBox that I've got open is cursed, and I'm going to give it another try. What's it? Win16.conf. Our old friend Win16. Will that show up on my list of things I can stream from? Yes, it will. Thank God for that. Yeah, alright. Windows. Give us the Windows. And then OBS is going to forget what the name of the window is. I'm predicting. No. No, it remembered. It figured it out. I'm surprised. Okay. Oh, and I forgot to mount the disc. Okay, that's on me. That's on me. Oh, because I mounted Media Band the other time. Okay, well. No Media Band this week. You have my word for that. That's, you know, once a month is too many times for Media Band. Alright, Eastern Mind. That should load now. Yep. It's Sony ImageSoft. And this other logo, which I can't skip. Alright. Do I have a save game at the right spot? I mean, the answer is yes, I do have a save game. The question is, do I have it in the right spot that I can use it from here? And I don't think the answer is yes. I think that could be a problem. There we go. Found the hidden menu bar. That's the first puzzle in Eastern Mind. Wait, it's not in there. What am I looking for? Oh, I'm looking for the Tree of Life. Okay. So let's... Yeah, let's load a game as Shah. Oh god, no, we're loading up the tower. That's not what we want. We basically want somewhere where we could very close to where we can die, so that we can... Oh. No, that's the opposite. We have to like hike through the minefield to find a way to die. Menu, there we go. Okay. I don't actually have a game in the right spot, so we'll just start from the beginning. Found a furoshiki. And a mullet. Yep. Okay. Oh, interesting. The face flashes when the lightning hits. Is that something that we do? I'm not sure. Okay, and we need to die. So we'll just go into the cheek here. Go into the fire. Throw away the amulet. And die. Yeah. Take the mirror. Oh, yeah. And we've got to pick. I think this character lives for a few seconds. Yes. Okay. Good. Yes, yes, yes. After this video. Yeah, see? So you see how there's this nice kind of glowy, pulsy effect going on? Pretty sure that is caused by manipulating the palette so that certain colors on the screen just kind of flash a nice color. How this is being achieved in the file, not sure. I'm gonna have to figure that out. But yeah, all of this was absent in the ScummVM version. So, ooh, can I save here? Am I allowed to save here? I'm not allowed to save here. But still. Anyway, so palette switching effects like that, as mentioned, very popular because they're cheap, they're relatively easy to do, and especially kind of in these early days of kind of like accelerated video, that was something you know, most video hardware just supported out of the box. Like, I mean, like it's kind of yeah, like Windows 3.1 wasn't really designed in mind with high performance kind of video and sprite blitty type activities. That was all kind of bolted on afterwards with WinG, which then later became DirectX. And I believe that's what Director uses under the hood to kind of get halfway decent performance. It does have a bunch of other stuff that it does as like a kind of speed hack. Like, I do know that one of the first things that happens when you try and run a Director app in Windows 3.1 is it installs a kernel driver. It has one bundled, I think, for like the sound driver layer, because you know, bog standard Windows sound driver API can barely play one sound at a time, much less like 4, which is I think the Director, you know, yeah, much less 4 at a time, much less being able to mix them all in live with a bunch of other events and such. Anyhow, okay, so that proves what we kind of need to see. Now, we could go and have a look at this first. We could go like straight in and try and figure out what's going on. Or we could look at something related but slightly different. So there's a demo that I found, which is, I want to say like a smaller surface area than that that palette switchy thing. I think the palette switchy thing in Eastern Mind might be script driven, but do I have it in here? That's the question. Let me check. Yeah, okay. Sorry, just copying it into the fake Windows install before I forget. All right, and hopefully that will work because it hasn't seen it before. If I can find my window. Ah, there we go, it's down here. All right. So, I think it's in CS. Yes, it's in CS. Okay. I think it's installed.exe, despite the fact that it's not actually an installer. It just shows a slideshow. It's in the folder. Come on. Oh, right. It's freaking out because I think this was originally... No, it can't have been on the Mac. Oh, it was originally on Windows 95. It expects a 9-letter word. Yeah, we don't have those. We don't have those here. Also, check out this cool effect here, right? So you'll notice that like the rest of Windows has now become this like delightful shade of green and magenta. And that's down to the fact that like when you have 256 colors, there's like a block of 16 at the start, which Windows kind of says, yeah, don't change these if you can avoid it, because that's kind of what Windows needs to look normal. What I do like about this demo, which I'll show in a minute, is that it does not kind of abide by that at all. Okay, I'm gonna quit because we need brain S thingy one. Okay, that's right. Have a go. So we'll just go.
I am Dr. Thaddeus P. Brain the Third. The P stands for puzzles. I am the puzzle master.
Okay. So the pellets are like absolutely ruined. I wasn't expecting that. Okay.
Nothing can go wrong.
Yes, nothing can go wrong. If you yeah, so what has happened here is that yeah, we've disproved that. Pretty much every screen has got its own unique palette, and what's meant to happen is that it just kind of nicely transitions between each one. That is broken for whatever reason, so it is like, this is more, I was hoping this would be kind of an example of what we wanted, but really it's more like an example of what not to do.
I play pretty good, Listen, Lichten.
And yes, this is a demo for Lost Mind of Dr. Brain, which is a Sierra game which doesn't really use any of their previous adventure game tech. It's all custom engine, so not in ScummVM yet, though it would be interesting to add someday. Very interesting that kind of like, this area is meant to be like all control panel-y stuff, and it's all redded out, so I'm guessing that the front screen must set that, and we just don't use it. But anyway, like, when I was playing the actual game, like, back in the day, like, the thing which kind of blew me away a little bit was that, yeah, that it was one of the first games that actually used a different palette for every scene, and you could tell because it looked like, I don't know, most 256 color games, they just use, like, dithering and, like, a really kind of limited palette, which is, you know, the case for Eastern Mind, and you can tell that it is color limited. But for something like this, if you just have a really nice palette picked for each scene, it's pretty difficult to tell. Like, it just looks like really high quality pixel art. So that's annoying. I would have hoped that we could. So I think it's because like it was asking for the song that. Yeah, it was asking for the song, and therefore it couldn't. Let me restart. It was asking for the song, which then meant it popped up a little dialogue window, which then meant that it got stuck in whatever the first palette mode was. Yeah, but the main thing, which you could probably see from that, is that it's meant to kind of show a scene, fade out using like the dissolve transition thing, and then switch to another one so that when it dissolves into the new one, it looks good and it doesn't look like doesn't look cooked. So okay, that's good news. That's really good news. Okay. Hey, Victor Hollow. Sleep paralysis demons. Okay, let us go back into the real world and see how. I think ScummVM deals with it okay, but it could be better. That is my recollection of how it is. Brain. What debug level do I want? I'll have it 5. That's always a nice number. Debug flags. Oh yeah, we should. There's probably like, if we just have like a quick squeeze in the source code, there should be some debug messages about palettes. Oh, it'll be frames, I think. What are my choices? Oh, it could be loading. Maybe it's loading. Let us say images and loading. I think loading is the one which has all the frame stuff, so we'll do that. Images, loading, director. I think that's the one. And we run it in the debugger because safety first. Yep. It might not be yet fully support. Okay, we're going to do it anyway.
I am Dr. Thaddeus P. Brain the Third. The P stands for puzzles. I am the puzzle master.
So you can see there, like it was transitioning.
All is ready for the master experiment.
So it's close. It's almost good. Like the one thing that is missing is that it should be switching that palette before we do the dissolve.
Nothing.
So it doesn't look kind of cooked. Alright. And I think this particular... Oh, is this... Oh, sugar. Maybe it isn't the one with the frame info. Maybe I'm mistaken. Oh, I just need more. I just need more debug. Okay. Let's try it again, but with more debug. Starting anyway.
I am Dr. Thaddeus P. Brain the Third. The P stands for puzzles. I am the puzzle master.
I see, okay.
All is ready for the master experiment.
Right. So it's like what happened there. So you can see here, like there's like frame 26, which was the one which did the fade to black, and then frame 27, which did the opposite. So I think if we go further up into here, Oh no. No, this isn't what I was looking for. Okay. Oh, close. There's like one debug message which I'm looking for, which is not read channels. Maybe it's on the score. It's probably the score. Let's render sprites. Load frames. There's like one debug message which has like the cast ID. Oh, well, okay, we've got that one that says current frame. But yeah, I thought there was one which basically said, oh no, no, sorry, we do have that. It's just there's only one channel. Okay. Oh, because palette, it won't print if there's a different palette, because I don't think we've got a debug message for that. All right, fair cop. I think we need some more information. I think we need to crack this open in Windows Director to see, just kind of confirm what we think is going on. It doesn't look like there's any scripts or anything. It's all just done with sprite transitions, which is nice. Saves a bunch of effort. Of course, to actually like pop it out of the container, we're gonna have to do a bit of illegal modding. A little bit of illegal modding. Okay. Oh wait, no. Have to get out the exe file, don't we? What did I call it? Ripdir from exe. Did that work? Yes, it did. Okay. So just move that to something better named, and then oh no, my dodgy tool didn't work. Ah, that's disappointing. What do you think the odds are that they actually protected it? Like, did they? Yeah, so to put things in perspective, like what I have here is just a bunch of kind of scripts that I put together which open up a director file, flip the bit on the checksum, which then means you can open it in the director, the tool, and then save it again. But yeah, that doesn't always work if the file that you've ripped out is broken. Did I mess up the first step, actually? Okay, looks so, yeah. It's a good old xfer. And then yeah. All right, nothing outwardly looks wrong with it, but it's very yeah. It's very hard to tell because these old yeah, the director file format, like you look at it and you think, oh, this is just going to be like a nice riff-like file format. Look, it's even got like riff in the name. It'll be fine. No, don't believe it. It's a ruse. It's riff when it's, you know, very, very skin deep level it's riff. But it also has to work on when you're saving to floppy disk, which then means it is totally fine to just, you know, append crap to the end and change like a table up the top. And then it is definitely no longer riff, which could be what happened here. But anyway, we'll try the path of least resistance first. We will hold on, I'll just copy this into like a folder that DOSBox hasn't seen yet. DOSBox will like refuse to acknowledge a file if you've been in the directory already, but if you haven't, it's game on. It's fine. So, for instance, this QTW directory, never seen it before, and hence here we are. It's appeared. Will director open it? Come on, it's in the file. Why would you need to protect? Oh, okay. All right. Be that way. I guess I better fix my dodgy tool. So what is going on here? Okay. So the buffer is empty. I see, okay. Let's try that again. Okay. Oh, and we should update the goal. Fix dodgy modding script. Gotta be honest, right? Okay. So it opens the file, reads it. Oh, yeah, okay. That's my mistake. I should have. This is, of course, a little endian. It's not big endian. Hey, okay. So it did something that time, but we've run into what could be like an issue with my checksum algorithm, which is that sometimes it does not sometimes it does not agree. Oh yeah, because basically what's happening here is that like there is one chunk of the file which is the config block of the file. The checksum runs against that, so then it doesn't have to kind of like mess around every time like one bitmap or something changes, or it doesn't have to like hash the entire file to check that it's not being stolen. Issue though is that and so yeah, basically like it gets the chunk, it then gets the checksum, and then it tries our checksum algorithm on that chunk to see what is going wrong. And while my checksum algorithm works on a lot of files, it doesn't work on all of them, and I think it's because quite a few of there must be a field or something there which is like a signed int or maybe like an unsigned int that I'm reading wrong. Anywho, we'll just the original algorithm I kind of sieved out of IDA Pro, but I don't know where that is, so we'll just do things a hacky way. Is platform. Okay, we go all the way down. That's our exe ripping code. And this is our... Oh no, this is just the... This isn't actually doing the checksum. The checksum is here. So you can see I've done quite a lot of... I want to say crappy workarounds to make... crappy workarounds to make kind of assembly style math work. Because, yeah, basically like... You know... It's a 32-bit number, which it then just kind of like multiplies by, you know, various things inside the file, and then when it overflows, and then after you've done all that, then it they use the secret, you know, the secret kind of cryptographically secure random string here to XOR it with, so that you will have no idea what the interior is meant to be. Okay, so my guess as to what is going wrong is that quite a few of these I've got in as uint16s, and I don't think they are uint16s, and that could be messing us up. I'll say we could go with these uint8s. So ignore the horrible split. I just need to look at what's in the struct. What is in the struct? Yeah, okay, so we've got length, int. Okay. What I probably should do... Oh, okay. So if I... Okay, that original chunk isn't exactly a nice format, but... Yeah, okay, alright. That might be something we can do. So I'll take that. Just copy paste that. I'll make myself a new terminal. Then we'll go, if we go through these fields like one by one to check if they could be misconstrued as a signed or unsigned number, then we might be able to get it going. How do we convert it to... Alright, okay. I think if we do this 2 bytes... Major len 4... Oh, okay. Oh, no, I got it wrong. It's bytes from hex. Major len 4. Okay. That's good. All right, and now we just kind of eyeball each one to see if we're in danger. Okay, so we've got okay. So that's unsigned. That's fine. That's unsigned. That's fine. That's signed. That's fine. That's signed. That's fine. Signed. That's fine. Signed. That's fine. These are all 16s, aren't they? Yeah, they are. Until we get to the next line. Ah, okay. So uint8. This strikes me as not being right. Uh, 11, 12. So 10 to 11, 11 to 12. Yeah, that's fine. That's fine. It's fine. It's fine. Oh wait, no. 18 to 19 is here. 181C, which is here. Oh no, I just missed one completely. That is odd, but then again, I did copy this from disassembly, so it must be true. And B, yeah, that's fine. That's fine. Both of those are fine. This giant thing, it's fine. It's fine. All of that looks fine. Yep, that looks fine. Then another uint8 here, not a problem. 4, 5, 6. Yeah. And 3A, that is here, there. It's fine. I bet it's that. I bet it's just that one. If it is, I'll be super pleased. Am I in the right spot? I'm not, because this wasn't the shell I was using. We gotta go back to here. Oh, and I also gotta save what I did. Otherwise, I'm not gonna get very far. Okay, quit that. Load that again. Load director. Actually, we don't need PDB, but hey, okay. There we go. So we've taken the checksum, we've broken it. Or sorry, we've flipped the one bit in here, which basically means file is fine, unprotected, and we've saved a new checksum, so we should be good to go. Let's go. Done. Where were we? Oh, okay. We edited it here, which should mean... Oh, wait. Okay. Means gotta copy it here to where Windows expects. Okay. Quit here. Open that up. Where is Brainsong? It's gone. There's no Brainsong. Yeah. And here we are in illegal editor mode. Okay, there is a script. Not... Okay. There is a script, but I'm guessing it does... Oh, I must play the... It plays the song. It plays the song. Okay. Don't care. What I do care about are these little things up here. So we can see that we've got different palettes. One palette per screen. Ooh, and we can like view all the wrong palettes. Yep. Horrifying. Whereas if I were to switch to the right screen, oh look, it looks fine and in the right set of colors. If we hit play, so it should dissolve out. Strange, okay. So it does like a kind of weird palette. Strange. I thought like last time I tested this that like it... Yeah. So you can see that like it does the palette... It does like a fade of the palette width to dissolve, which is an interesting choice. Anyway, let's go back here. Let's slow this transition down. Dissolve pixels. Dissolve bits, and we'll give it like a good 5 seconds so we can see what's going on. Likewise with the transition going in. Dissolve bits. Oh wait, it's quarter seconds, ain't it? Okay, 16 with a chunk size of 1. I should do the same for the other. All right, let us pray. That is very strange, but I guess it must be deliberate. Let's go back here. I want to just see that again. Yeah, so makes sense. We don't have a palette change instruction, so it just goes to black. But then it fades it in while it's doing that transition because it's on the same frame. Okay. And I guess because it's meant to be kind of like, you know, you're not gonna get too annoyed at that. But you can definitely. So I guess this is, yeah, this is gonna have to be behavior that we fix. Because I'm pretty sure it's, yeah, all right. So, okay, I think we've seen enough. So the palette is on the same frame as the transition, and I think we just set it in the current code. Anyway, we'll just. Oh, I should commit that before I forget. Cool. ScummVM code, that's what I'm after. All right. So we've got, yeah, all right. So at the moment, yeah, the transition code does not take into account the palette at all, which I respect that. I can see where they're coming from. But what they kind of need to do set. Oh, okay. Yeah, just go set palette. So possibly what we need to do here is that we need to kind of, we already have render transition, which would have the palette ID for the frame that we're using. And I think it might have to actually just do some kind of like dirty tricks in the transition code to sort that out. Have a quick look, because it might be kind of a bit more difficult than the Eastern Mind problem. The Eastern Mind problem, I'm guessing, is going to be scripting, but it, yeah, could be related. Didn't have to look far. Yeah, okay. Oh, and then it calls that code in window, which I know all about because I've been messing with it in a branch. Okay. Try again. Oh no, it's not there. It's in graphics.cpp. Play transition, of course. It's not. Gosh, I wonder where it might be. Yes, that's what I'm after. Right. All right. Where? Yeah, and it takes a frame ID. Oh, okay. So like one thing that I think we need to kind of sort out. We have, yeah, okay. This thing here, GDirector set palette. So I think what we're going to have to do in order for this to work is that in the event of a new palette being picked on the same frame boundary as a transition, we're going to have to like, I don't know, we already have, sorry, in here in transitions.cpp, we already have what's it called? Step transition. So yeah, basically each of the transition kind of transition methods calls this, which does GDirector draw. We might have to rig this to update. I think, yeah, what we're going to have to do, right, is that when we're setting up a transition here and play a transition, we're going to have to make a new palette buffer, which contains a copy of the current palette. And then every time we kind of step into a new frame, we would need to mix whatever the target palette is and against, yeah, mixing the current frames palette against the next frames palette. But then if we have like this one little kind of buffer that we keep hold of in the transition code, then we should, then that's good. We don't have to worry that much about messing with the palette on the score. That can remain where it is. That, like, after the transition, that will get set to the right thing. We just have to kind of deal with our own, except, oh, okay, that's a key thing. Is set palette, does that take a buffer or does that take a palette ID? If it takes a palette ID, then we're going to have to hack it a bit more. And yeah, all right. Oh, it's in graphics. Okay. I've got graphics open. It takes an ID. That's... Oh, no. No, you can do it manually. That's what we like to see. That's what we like to see. Okay. This is rapidly becoming its own thing. Let's go. Transition palette shifting code. Okay. Yeah, we've got current palette and past palette. bits per pixel. Okay. All right. Okay. A plan is taken shape. So let's look at transitions. Well, we're gonna have to. Yeah, we're gonna have to make a buffer. So let's go make a temporary buffer for palette shifting. I think the palette is 6 times 3. I think that'll. I cannot remember the C syntax for an empty array, but that's fine. We'll just leave it uninitialized. It'll be fine. Memory safety. Yeah. Okay. What we're gonna need, I think, is that we're gonna need a pointer. We're gonna need 2 pointers. We're gonna need a pointer to the current palette and the palette that we want to mess with, which would mean it'd be nice to reuse this code, but we can't because it modifies this, which we don't really want to do. Is this in... Oh, this is in Window. It's not in Director Engine. That's annoying. Oh. Oh, for real? Okay. Actually, you know, let's try it. Let's go. I'm consciously thinking here that we're gonna have to do some kind of patch in here to support non 8-bit color. I don't know what that's gonna look like yet, so I'm just gonna pretend there's only 8-bit color. We can always fix it up nice later. GDirector load palettes. I think if we just do a wee bit of copy pasta. And it was palette v4, okay. Okay, so really it should be if frame. Okay, frame is just that. Well, what's the... do we dereference it at any point? Oh, okay. So I think... Yeah. So all this stuff, I think, gets scraped out and put into there from somewhere else, potentially a render transition. That's the deal. Yeah, okay. It does all that. Does all that. Palette ID. Okay. little shonky, but it'll do. Oh, does it check to see if it exists? No. No, it does not. So that must always exist, which is good news for us. Yep, okay. Duration, trans area, chunk size, TV type. Let's just leave that 0 for now. Yes, I know. Oh, some graphics. No, graphics is the set palette stuff. It's non-transitions, score. That's what I'm looking for. Palette ID. Okay. What type is that? It's an int. Of course. Of course it would be an int. Okay. All right. If palette ID I think that's the right type. How would I even check something like that? Oh yeah, we can score, I think. Current. Oh dear, okay. That's I see. Okay, so current palette on the what's it called? Current palette on the score is just a bunch of bytes, which is fine. We can work with that. It's just messy, just real messy. Oh, but no, that's fine. We'll just do things the dodgy way. What format was source lang? Was it a uint16? Yeah, uint16. All right, how about we initialize the palettes both with whatever's in current palette? Like, then if we specify a different thing, we can then override it. Yeah, okay, because then, all right, makes sense, right? All right, so to put things in perspective, right, you can see here that they own, like, despite the fact that we have a whole bunch of frames that are just blank, you don't have to repeat the palette cast member over and over again. It just, you set it once and then it remembers for the entire thing. So that will mean that if this is anything other than 0, that means we've got to do a palette swap, which is good because then we can grab this. Do the admin later. Quit trying to be helpful. Target pal equals target. Okay. I was gonna. Oh, it's gonna whinge because it's private. It's private. Unless. Oh wait, all this stuff is private. Of course. All right, so how can we work around that? We can just pass them as args, I guess. Like, we do the dirty work and score. Score's a friend, which basically means you can just ignore inherit. Like, you can ignore private members, which is quite nice. And then just shunt it over here. That's tempting, actually. That's got it's got a nice ring to it. Makes this call signature real messy, but I don't know. Beggars can't really be choosers, can they? Oh, the other option is that we can just expose these values. Like, we can make getter functions in here. But that would also be messy. I'm inclined to just load, just make this the most top heavy method possible and just put in 4 args there. One for palette, pal length, and palette, pal length. And that will mean, okay, so that will mean like taking what we're doing here and moving it to score where we have all the stuff. Which would also mean messing with puppet transition and co. No, it wouldn't. We can just, okay. 4 nulls. Going to hell, but it's fine. It's worth it. All right, so the things we need: source palette, target palette. Okay, so go. Okay. This is now all wrong. I'll just nick that from here. Two adjacent parameters of thing are easily swapped by mistake. You know what? True. Probably true. So let's make frame do it at the start. Like while we're here, let's do a tidy. Let's make that the first arg. It's got big first arg energy. This then we got to go back to score and make frame ID, all that. Oh wait, okay, yep. So I think we still got to do GDirector. Actually, you know what? Pop that in there. Jam this in here. Oh. Not good. So the okay, so the tricky plan isn't gonna work, at least how I thought it's gonna work. Because it's actually in Director Engine, and we're not in Director Engine, we're in Score. Given that we're in Score, so wait, what? Yeah, current palette, last palette. Sort of palette ID. Oh, did I make a mistake? Oh. So source pal. Where did I think source pal was? Oh, I thought it was on director as well. That's annoying. Okay, timeout. Let's rethink this. Okay, so if it's on the main director class, then we got to do some work. We got to do some painful work. We got to do some we got to do some refactoring, but it is no longer worth cramming this up here because we're not actually getting it from the score. So we've just lost a big argument about neatness. So we'll go back to having palette ID and we'll just make it exposed in the proper way. Go back to here. Thank you for the concern, Beanstalk. We'll try. We'll try to be careful. What are we gonna do? We are going to... You do that thing where you kind of like defocus your eyes and you turn away from it and it's like, what was I about to do? I have no idea. Oh, that's right. So yeah, okay. We rolled that back. We got to roll back a bunch of stuff we did here because this is no longer... No, get rid of it all. It was all a mistake. Mistake. Oh, not all a mistake. There was one thing that I liked, and that was that we should move event frame to here. I should also do that here in play transition. Okay. All right, so we gotta find a way in Director Engine to. We just gotta make some getters and setters. It's object-oriented programming. People love getters and setters. Accessing stuff. Getters and setters. Where is Director Engine? Would it be in director.h? Is that a thing? Yeah, okay. Oh. Oh, okay. Oh, so we do actually have get palette, which should be good. We don't have get current palette, which is a problem. And it would be nice if we could do get current palette, which is palette v4, because if we did that, then we wouldn't have to do two methods to get the length as well. We just get everything in one spot. Get current palette, because I think that struct has the ID in it as well, which would be good. Tell me things about get palette or palette v4. Yes, it does have the ID in it, so it's like it's exactly what we want. Okay, and that crap is in graphics. How did I miss get palette? Where's get palette? Oh, it's here. Okay. I see. All right. I will be curious to know. Does this thing actually get used? Like, do we set a palette as raw bytes and raw count anywhere? Because if the answer is no, we should really be just keeping track of this pal object or something similar to it, because that way then we have the trifecta. We have ID, we have the color data, and we have the length. We don't have to keep track of color data and length by itself. Actually, you know, we must be keeping track. Like, we have to be keeping track of what the current palette ID is, because there's Lingo script which allows you to edit it. Lingo. The frame palette. Okay. All right. Score, get color. There. Wait, it's in score? I thought we went through a whole thing saying that get. Oh, right, because it's just getting for the individual frame. Technically, yes. All right. Rewinding to where we were. So to yeah, it would be really nice if get current palette would return a full one of these. We want to know, okay, is this overloaded version of set palette used anywhere that could hurt us? Because if it's not, we should probably get rid of it. Yeah, I've got it here. That's the definition. Using the ID, that's good. Using the ID, that's also good. Using the ID. What's this? Oh, what? What's that? What the hell's palette lookup? Oh, it's some kind of ScummVM thing. Okay. Yeah, okay. This must be some kind of special internal ScummVM class for doing RGB to palette stuff. Okay. Don't care. That's fine. That can have a set palette. I'm fine with that. These two. Okay. What's the deal with this? Oh, okay. Yeah, right. So it's doing some kind of video stuff. Goodness me. All right. Okay, so we'll keep it. We'll keep it for now. That's a bit annoying. Bit annoying, but we can live with it. All right, well, yeah. Again, path of least resistance. Let's just... Oh, actually, you know what? Sometimes it's hard to know. Sometimes it's hard to know what the cheapest way is going to be. because we've got set palette here, which loads up the right one from loaded palettes and then sets it properly. And then we have the Mankey one here, which just sets these two things. Are these actually used? Okay, let's check how difficult it's going to be to refactor this stuff. So is that going to be? Is that used in a bunch of places? Yes, it is. Okay, well, we're not gonna. Yeah, okay. Let's not move this into another structure unless we absolutely have to. Okay, cheapest way possible. We're just gonna have like a different method for both. That's fine. I can live with that. I can survive. So we'll just go get current palette. Oh, that should go in here. It doesn't quite, it doesn't match up, but it's fine. No one will notice. Okay. Why is this, oh, because I messed up. Yep. Interesting. Well, how do we do that? I thought that that was a const byte. Are you allowed to reassign it? I guess in C that's fine. Rust would absolutely just lose it at you if you try to do something as egregious as this, but apparently in C++ it's fine. So who can say? Who can say if it's bad or not? Good. This is good. Alright, so after a lot of kind of monkeying around, we have pretty much everything we need to start muxing. Tricky part will be, yeah, okay. Because we have several different points in this code which actually do the frame rendering. Like, it's kind of all over the place. Like, there's some in play transition, there's some in dissolve trans, and some in another one which has a name that begins with T for trans multipass. Yeah, at least 3 different spots, which all do, yeah, which all do this step transition. Now, okay, so what, the way that we want to do it though, so we basically need to fade the, yeah, so we need to be able to fade nicely. And to my mind, it looks like it's just, it looks like it's just doing an RGB fade. And that's kind of the cheapy thing that I would, you know, that's the first cheap thing I would do, because that seems like it'd be pretty easy to compute. Just, it's not doing anything kind of like too clever or anything. We'll just have one more squiz at it. Yeah, it looks just like a linear blend between color A and color B. So I think that's what we should have a crack at. Thing is, in order to do this, we need to have kind of like a per frame hook. Like, because you can see here we've got this steps count. This steps count can vary, like, you know, depending on how long the transition is, depending on how granular you make it. So what we would need to do is, to get our blend index, we would need to, yeah, we need to use this to calculate what the blend index is going to be, which I think we can do. Oh, yeah, okay. Right. So my thinking, right, is that, so like, for an example, we can get the kind of, we know it's going to be, are we just going to assume that it's 256 steps? Like, that seems like it would be a good, oh, but I mean, if we're gonna do it nice. I mean, yeah, because like immediately my brain was just kind of thinking, okay, 256 colors, we do 256 kind of graduated steps, fading through the things. We don't, I mean, we're not bound by that. We could do a color change for every step on the way, and it would look amazing. Well, I don't know. Maybe not amazing, but it'll look smoother than it did on the original hardware. I'm tempted to go down that route. I think that if we have, if we pass the step, if we pass the total number of steps and the step count to our friend step transition, because step transition is the one that does the draw, and we would need to change the palette before we do the draw, I think. Yes. Yeah. I think that works. Yeah, okay. I'm liking that. So go in here. We'll go uint step unit steps. What else do we need to give it? Do we need to give it the palette ID? I get the feeling we're going to need to give it the palette ID. Oh wait, no, transparams are like something that we... Yeah, transparams are like things that we mess with. Or like things that we make. The question is, where is it defined? Yeah, okay. So we can totally, yeah, we can definitely like define the palette ID stuff in here. That'll save us a ton of work. And yeah, this is just going to be defined on the stack, so we can just do that in what's it called? We just calculate the palette in the thing. Okay. What are our types? Const byte and uint16. Oh, and we gotta zero it out. Gotta you know, do the right thing. Memory safety. Memory safety is so important in C++. So zero that. Oops. Oops. Copy all of that. And now this becomes stuff on T. Good. Good. All right. So that's looking pretty good. Next step would be to go into step transition. Yeah, this thing. We'll now give this. This now needs access to our transition information, which, if I recall, was transparams. Yeah. Okay. Good. So we'll do that. Yeah, sorry. We don't keep track of step in transparams, so we'll have to provide that as a second argument, but I think that'll be it. Now we're just going to go through to all of these calls to step transition and make good. Oh wait, no, it's I. Of course it'll be I. Oh, T and I. T, I. Is there anywhere else? Yes, there is. Okay. Let us extend the definition of exit transition to have that as well. Okay, that's... Oh, yeah, and now we can go T and son of a gun. Oh, we're gonna have to include I as well. We're gonna have to include I as well because we're exiting. Oh, yeah, and we gotta fix the definition here too. Right. That's looking good. That's also looking good. Just jam that in here. Jam that in there. Right. How was it that it did that palette swappy thing? Okay, so yeah, it just did this. So we'll go if T doesn't equal T target pal. Okay, I think, and here I believe is where we're gonna do our dodgy blit. You know what? There is... So a question that I have... I'm just assuming that this is 256, but it may not be. In fact, if we look at some of these... Is that 256? Yeah, it is. Okay, it's 256. They've extended it out by just covering it in red and green and junk. I suppose that's fine. Man, the palettes are really different. But okay. That makes me think. That makes me wonder. What color do we use when there's no, when it's? Do we just use black when there's no color? That seems like something that we should have a handle on. Like, pass palette. You know what? Bugger it. Let's just pretend. Nothing matters. Everything is fine. So we've got our temporary thing. Let's do just a cheeky for loop. I is less than 2d6. I plus plus. Oh wait, no. Maybe 768. I equals... And what's the right way of doing this without using floating point? There's got to be a way, right? Or we could just use floating point. Floating point's looking real appealing for me in a kind of laziness sense. But I'm just going to assume that if there's no color, then we're just going to assume it's black. That might be wrong. We'll see. It's not the kind of thing you can hide very easily if you've messed up half the colors. To source pal. So actually, to source pal I O. So we're just gonna do a kind of cheeky little inline palette lookup thing. And then to get there, how are we gonna do this? Because it is a byte. Bytes are kind of notoriously they're not that great. They're not that great for kind of blending. Because I mean, like I guess we could just do it like the kind of the nice old integer way, which is that if we could have two ints, and then we multiply them, like, so yeah, we put each of the color, like the colors, or you know, the number from 0 to 255 into an int each. We then multiply that by the size of the transition. Oh no, we can multiply by the frames. Yeah, okay. No, I'm liking that idea. Let's just do it longhand. Okay, so we'll go int. I'm hoping the compiler will be nice and optimize this out, but if not, it's fine. We will live. We will live. So if we go source call yeah, okay, so we go source call times t, it'll be step. No, sorry, it would be dest call times step. Subtract source call times t steps minus step. Yes, that sounds about right. So, yeah, so at step 1. Oh, no, I've cocked it up. Yeah, sorry. On step 1, source call will be full. On step 0, dest call will be, be kind of empty. So we take all of that, to an integer divide. God, how wasteful. By t steps. And then cast down to byte. Except, oh wait, C++, we should be doing, we should be doing special casts, I think. You know what, if you have to ask, use the special cast. Static cast byte. I think that's it. I think at the very least we're going to ruin the colors, and that, if anything, has got to be more interesting than me like writing stuff. So from a content generation perspective, let's give this a red hot go. Oh no, I messed up. Null pointer. Oh, okay. No, I still messed that thing up in score. Okay. There's no pointers anymore. They're all gone. I got rid of the pointers. It is now 0. Uh-oh. Yep. How am I looking for... Ooh, okay. RAM is looking a bit constrained, which is not ideal. How much RAM we got? Oh, we got 4 gig. That should be fine, right? Not gonna run out, am I? Okay. Whoa, that was using up a lot of memory. Okay. That should be fine. Sorry, my computer was just kind of making like the kind of slow down noises, which typically means that I'm almost out of memory. But we seem to be okay, so let's give this another stab. ScummVM, ScummVM. Everybody loves ScummVM. Let's just see what happens. I forgot something. I forgot to do something. Or did I? Did I actually? No, I am setting the palette. I am setting the palette for like every step. So, no. I take that back. It should work perfectly the first time. Get review. I crashed. Of course it crashed. Why did it crash? Memory safety. Our friend memory safety. Palette 2 not found. Okay, because it's getting the ID. How's it not found? Like, yeah, it's there. It's cast member number 2. Why are you having a fit at loading cast member number 2? Add palette. Is that a bad? Is that a messed up? Yeah. More information needed. Oh, no. Yes, definitely more information needed. Turn on all the loading debug spew and also at that breakpoint. Gimme. Okay, so yeah, it's loaded all the cast members, which should include, yeah, includes all the palettes. That should be in there. Wait a second. Oh, we've got get current palette. What is this then? 180. Did I double up? Okay. Oh my god. Okay. So we don't need these. We've already got 2. They're exactly the same. Okay. Okay. Why don't I use those? Let's. All right, we'll clean them up. We'll clean them up now. Oh, I just used them. There. Okay. Well, we can sort that out. Let's get palette and get palette color count. It always pays to read, kids. You we don't need. Rebuild that. Was that a change I made? Oh, okay. It's unrelated. Unrelated to the current set of work. That's all that matters. Get out of this. Load this back in. No, not you. Start. Okay. Oh, okay, and it segfaults immediately. Because there's null. Okay. I see it. Okay. So I don't actually need to do a bounce check, but I do need to do a pointer check. That's fine. That's on me. Why I couldn't find it is troubling. Like, cast member 2 is there. It should have just found cast member 2, but we'll look into that. Okay.
I am Dr. Thaddeus P. Brain the Third.
All right, get to that transition.
P stands for puzzles. I am
the
puzzle master.
Okay.
All is ready.
That didn't work.
Master experiment.
But it looks like it's trying. It's trying to find the palette and it can't get it. This is strange because why can't it find the palette? Like, it finds it here. It has no trouble finding it here. Oh, oops. Yeah, okay. I didn't put this in. I didn't put this resolve valid ID thing in, and you need that. I'm guessing because there's... Yeah, okay. That's on me. That's on me. Where's resolve palette ID? Okay. So really we should be doing it here. Because yeah, it's something that's in the score, and so yeah, we should do it in the score, or look it up in the score. All right, we're getting there. We're making progress. It's not crashing anymore. I've managed basic memory safety, you know. Things can only go better from here. It'll be fun. Come on, give me the window. Okay, yes, start.
I am Dr. Thaddeus P. Brain the Third. The P stands for puzzles. I am the puzzle master.
Okay.
All is
What was
ready
that?
for the master experiment.
Alright, well I learned that palette switching is apparently very expensive in ScummVM. And also, my math is off. Doing? Why is it so strange?
I play pretty good, Listen, Lichten. What, I gotta do everything? Nothing.
Like, so it's like, is the step calc wrong? Is the step calc wrong, then it's overflowing it'll be overflowing a buffer if the step calc is wrong. I think. Ooh. I'm just kind of worried, because like it's a very kind of strange, like if the colors were completely wrong, I'd understand. I really would, but they're not completely wrong. They're slightly, they're remarkably consistent, and a lot of them look like they're coming in from black, which I do not get. I think we need to put in a debug string. Maybe a debug string would let us know what's going on. We can't put in one per frame because that'd be dodgy. We can put one at the beginning of step transition. We already have a debug message. I thought I had like a big... Oh, that's on my other fork. Okay. I have another fork which I put a whole bunch of debugging in for the transition code. This ain't it. This doesn't have it. Alright. Well... let's go to here. Alright, let's put in a breakpoint here, because we know that we're gonna only hit this palette code. If we're gonna do the color blendy thing, we're gonna hit this line. So we're gonna put in a cheeky breakpoint there at line 177.
Whatever. You figure it out.
Maybe I will figure it out. You don't know that.
Listen to me, Uncle.
Okay. First frame. Yep, okay. We have our palette, we have a length. So the real question is, why is the math cooked? How did I cook up the math? The math being the math that's in step transition. Does this need to be there all the time? Am I committing memory safety crime? I just realized. Does this pointer have to live? Because if it did, that would be a shame. I'm going to assume it's not a memory safety crime. I'm going to assume that it's all good. Fuck. Oh, the only way of telling if it's a memory safety crime is by actually breaking into here and then breaking into whatever that sends it to see if it's good or not. Okay. One way that would ensure that it is not a memory safety crime is if we load this in here. If we load this in transparams, by definition it cannot be a memory safety crime because this will be persistent. This is not part of the... It'll be on the heap, not on the stack. Because... Oh, yeah, because, like, what my concern, right, is that, like, we set the palette. If this just says, gives a pointer and says, hey, you can now use this for your palette, it's not guaranteed to exist here outside of this scope. And that's a memory safety crime right there. That's you know, if this were Brasseye, this is the one thing we didn't want to happen. So we gotta make this safe. We gotta make this memory safe. We gotta go back into here and fix our memory safety crime. Going in and but doing this. I am drawing a complete blank as to how you meant to... There's like... Oh, I swear there's a C++ shortcut for initializing a big list with 0. And I can't for the life of me remember what it is. Because I don't have to type out the number 0 768 times. That's just not happening tonight. I don't have it in me. Huh. Apparently you can do that. Well, I'm not going to look a gift horse in the mouth, so we'll go... that allowed? It's not complaining, so I'm going to take that to a sign as that is perfect C++. I'll get rid of that. And we'll use the one on here. All right. I think that fixed the memory safety crime. Oh, too eager, too eager. Gotta wait for it to build. You can't just run GDB. Gotta wait.
I am Dr. Thaddeus.
Yeah, you've said that.
The
Okay.
Third.
Is it gonna work?
The
Is it gonna
P
just...
stands for puzzles. I am the puzzle master.
Alright. I'm cocking something up. I've got to be cocking something up. It's meant to be RGB. Why no RGB? Unless this math is messed up. I'm now starting to think that maybe we shouldn't actually make it like do it every frame because it seems a little expensive, but you know, that can be sold in post. This on the other hand, we gotta sort out now. It's getting messy. Right, so byte is an unsigned number. It's got to be an unsigned number. Let's do this the cheap way. What is the name of the command I'm thinking of? Debug C. Maths. D. Oh, this is gonna be like a lot of stuff on the screen, but don't care. Not gonna keep this. This is just some temporary instrumentation to see why my math is so bad. Because judging by how jumpy the colors are, it should be pretty obvious as to like where I'm messing up. Eight images. Okay. Oh. Windows step transition. Wait, don't do that. That's not what I want. What I wanted, but messed up saying, was 148 of transitions.cpp. Now you can go. Because it's important, we only want the breakpoint to trigger when we're actually doing a palette shift, not every single frame. That would get tedious. Unlike this, which is, yeah, super engaging. All right.
I am Dr. Thaddeus P. Brain the Third. The P stands for puzzles.
Okay. So let's have a look at my... Okay, already I can see math problems. What is my step? 0. Okay. Oh, yeah. Whatever I'm doing, this isn't maths. Like, last time I checked, 244... The difference between 244 and 244 is not 12. Or rather, like, that should also be 244. And yet we don't have... Okay. Target call times step. All right, I'll put a breakpoint in at. Okay, good example. So, what should be happening? Okay, step is 1. So that's... Why is target call times step equaling 0? Like, that strikes me as... That strikes me as, like, not good maths. Oh, no. No. Target call times step. Okay. That's good maths. Yeah, good point, Victor Hollow. 244 and 256 is 12. Yeah, there is some kind of overrun, or, you know, it's basically downcasting to a byte. We're missing what either there's something wrong with my maths and it's getting downcast the wrong thing, or there is something else I have not yet taken into account. All right, so yeah, looks like my maths is cooked. That's a technical term, because if I get rid of that, that is also more than a... That is also... That is more than 32 bits. And because I'm using unsigned, aren't I? I'm using unsigned. Okay. This here, not big, not clever. That's just... Yeah, okay. So, for those who have not kind of tripped up over this before, when you have an unsigned int, that basically means negative numbers, they don't exist. You just go to the biggest number, which in this case is... 4.2 billion. So whenever you see a number that's around 4.2 billion, you know that you've screwed up and you've hit a sign inversion. We've been okay. Okay, understand. Makes sense. Negative numbers, they're good. We love negative numbers. We're gonna keep those. So say that we were to do that. We can actually test it here. So say that we do the right thing. We cast this as an int. We cast the other one as an int. It's still going pear-shaped. I'm guessing because this is... Yeah, okay, it's probably just going to be because of this. Because this is going to be unsigned. This is unsigned. Oh no, it's not. It's signed. Step is... No, step is not. Step is unsigned. Okay. So you can't have a negative number because it then just goes to the biggest number. Okay. Right. For the sake of whatevs. This is all stuff that I added, so can I... Yeah, right. I don't want to have to cast it again. I just want to do it right. Because, I mean, like, step... Yeah, steps are all ints, so... An int it shall be. What am I missing? All right. So that's an int. Oh, I see, okay. That strikes, okay. That should be good now. That's an int, that's an int. Those are both ints. This should all kind of, the C compiler should look at all that and spit out an int, and it should divide it by another int, which then means we should be fine. Okay. I have a good feeling about this.
I am Dr. Thaddeus P. Brain the Third. The P stands
It's gonna be even
for
more slow, but I
puzzles.
don't care.
I am the Puzzle Master.
It's still cooked? Why is it still cooked? I fixed it. Yeah. What gives? I'll just throw the frame ID in there for good luck. And jump up to line 148. Come back.
I am Dr. Thaddeus P. Brain the Third. The P stands for puzzles.
Does it now? Alright. So, let's have a look at our maths. Maths is good. And again, okay, the maths is cooked. I've made a math mistake. What's a color which has good stuff in it? Number 4. There. Okay. Source call to target call. Should be fine. In reality, what do we get? We get... yeah, okay. Oh. Oh, I see. Oh. Okay. I'm not good at maths. Oh, or rather I just... Okay. I wasn't quite thinking of that one. Tell you what, how about I cheat and have a look at how I did it in my Python library. Because like color muxing, that's a solved problem. We've done that. So it's B times A times alpha plus A. So how am I cocking that up in here? Oh, because it's the other way around. Oh, because I meant to add it. Because the minus is already in here. I made a mistake. Okay. Yeah, okay. So I kind of knew that, like, oh, you got to subtract, like, the difference of one color from the other, but I did it twice. So I was actually subtracting the difference of the difference, which would then roll around. So the way that it's set up now, it should never under flow because either target col or source col will be yeah, because like this number should always be positive, right? So that means like you're adding a positive number to another positive number, and because of this step grading factor, it should always be under the top. Okay, there we go. That's my mistake. Math stake. God. All right, rebuild that. You know what? Actually, no. I'm so hopped up on my own sense of self-confidence. I'm going to remove the debug line and I'm going to give it another shot. Come on.
I am Dr. Thaddeus P. Brain the Third. The P stands for puzzles. I am the puzzle master.
That almost looked good. There's a kind of... Okay. Yeah, towards the end, it looked a bit manky. Like, it was getting there, but it looked like it had been... Yeah, right. So... Don't like that. How about I bring this back, but just for one color. We're gonna pick a color that looks interesting from the scroll back, which I got rid of. Oh, it's fine. If I equals 139, that sounds like a good color. And then we'll print out this transition. Because yeah, like the fact that the end color looked kind of black means that it's dividing too much. The step count, yeah, the step count isn't quite doing it. T steps.
I am Dr. Thaddeus P. Brain the Third. The P stands for puzzles. I am the puzzle master.
Yeah. So the back is all kind of weird and grody. Okay, so we've got 64 steps. And for the most part, it seems to be... Well, yeah, for that color at least, it seems to be transitioning it okay. Why don't I make it 4? Let's make it color number 4. Because that was... I remember that from the scroll back as being... I remember that being like in the 240 range, so that should be like more of the dynamic range. I don't get it though. Like that's pretty close. Why does a whole swathe of the color look kind of bad? Okay.
I am Dr.
Yeah.
Thaddeus P. Brain the Third. The P stands for puzzles. I am the puzzle master.
Yeah. Like the brain is not colored. Why isn't the brain colored? Why isn't the brain colored? Like, it's that first row. Hang on. Because gotta remember, in Director Land, all the palettes are backwards, so it's that last set of colors that it doesn't like. Because the original, maybe the original palette is smaller. Maybe the original palette is smaller. Because, like... Huh. Right. I'm not missing anything, am I? Because yeah. I'll just mix the channels. Oh, because I mix them with... Do I mix them with black? And is that a problem? Start again from the beginning. I didn't actually think of checking to see whether or not these were 256 or not. I assumed they were. Oh. If that's 256, then we're only changing... Okay. New failure mode. We're only changing the bottom third of the palette, because I'm pretty sure this is going to be 256, and we're doing it times 3. So, yeah, that's my guess as to what's going on. We'll start again. I'm Dr. Thaddeus P. Brain the Third. The P stands for puzzles. I am... Oh, I forgot to set a breakpoint. Step transition in line 147. Yep. That's my mistake. All right. That explains it. So rebuild this, quit GDB. Wait for that to come back. Come back any second now.
Dr. Thaddeus P.
You know, I've always wondered what the P stands for. Oh, sorry, preempted.
I am the puzzle master.
More like P stands for we've fixed the palette problem. Or palette problem plastered.
Nothing can go wrong.
Performance is still kind of
Nothing.
not great, but you only have to worry about it when you're doing a palette shift. So, how are we looking for code? I think that's looking pretty commit worthy. So, any other white space that I messed up? And last one in here. In transparams. Oh, yeah. Okay, fantastic. Palette problem puzzle indeed. Okay, that's good. I've forgotten how this works. Okay, palette is done. So, best commit that before I forget. That's all palette code. Mind of Dr. Rain demo. Cool. So, with a small detour like that, I guess we should really look at what's going on in Eastern Mind. I'm hoping it's not going to be quite as kind of from scratchy development as that. Again, fingers crossed. It's probably going to be just a scripting bug. So, let's go to that. Let's go into. I think we can just open the file. We don't have to actually start Eastern Mind every time. Which is good. Start movie. This is where I need to look at. Okay. Yep. 1 second. I'm just logging into our good friend Trello so I can get the card that I needed. Actually, no. No, I can't. That's too dodgy. Please, Trello. I want to just look at the card. Yes, I know. Artog. Okay. Artog. DXR. We want to run with GDB. And let's do it with loading and lingo exec. And let's delete the scroll back. Oh, because I'm in the wrong spot. That'll be what. Yeah, okay. My bad. Gotta do it from here. And I misspelt it because I was hurrying. I was going too fast. Okay, well we've done memory safety crimes, we've done math crimes, and now I'm guessing we're gonna, well, maybe it'll be scripting crimes, but it could also be okay, movie. Yeah, no glow. Why no glow? Also, why no playback? Did I misspell it? Oh, yeah, I misspelled it. Okay. Because it should be, I was wondering, like, normally the screen should just be filling up with just every single script that's being run. And in this game, I'm assuming there's a billion scripts running at any 1 second. Wait for the memory safety thing to load in. There we go. Okay. Yep. I'm not seeing any per frame stuff happening. Set channel. Is it set channel? Oh. Okay, that's no, setting the foreground of. This I haven't seen before. But yeah, like during the flashing bits, it's doing some replace widget stuff, but it's not pulsing the tree. Why no pulse tree? Also, why are you still here? I think we got to open this up in Real Director, see what's going on. So let us take that file, which is Tongno RRTOG. Yeah. And hit it with the script. Oh, I should do it from the right spot. Windows 16 does CS. Cool. Do I still have this open? Yes, I do. I'm gonna have to. I think I'm gonna have to leave Windows for it to show up. Yeah, I'm gonna have to leave Windows for it to show up. gonna have to leave DOS for it to show up, which is less than ideal. But we can make it work. Okay. Windows. Alright. Fingers crossed there aren't sometimes if you have a director file and it has a bunch of scripts in it, loading it will crash the computer, but I'm hoping that'll be fine. Oh, come on. Come on. Oh, okay. Not today. We can't load it here. Although, we have another option. We have option 2. I think this might work. Well, one way to find out. Short version is the Mac version of Director is better written than the DOS version or the Windows 3.1 version. So there is a chance that we can open it there, even though we've hacked it. God, it's messy. By name. There we go. Win 16. Does CS and I think we can open it here. Assume I go to the right. The right disk. Haha. Yes. Thank you, Mac Director devs for not making something that crashes. Oh wow, this isn't actually a movie. I just kind of assumed it was a movie file, but no, it is a bunch of still frames. That's cool. So what's pulsing the... Huh. So if I were to hit play... I can't hit play because the scripts are missing. Okay, well, nevertheless, do we have any palettes? We do. We have a changing palette. Oh wait, do we have the same palette, but it gets... Okay, we have a palette cast member here, and it looks like to be the same one. 203 cycle palette. And what I'm guessing is that we have a script which messes with that palette and causes it to do the fadey thing. Okay, this is a good start. What are we gonna do? We are going to go back in here. Go into here. Run project arrays. Yeah, let's run project arrays. Dump scripts 2 of Keep it tidy. To scripts. Mac to Unix. Everything. Wait, I thought it, so it's cast member 203, which is still in this file. Cycle palette. Oh, okay, this is just the stuff that teleports you, because basically, every time you die in the game, you get taken back to the screen, which then kicks you to the place that you're meant to start your life. So that's all code for that. What I want is code for the cycling the palette, which I don't see. Maybe it's in a shared script. It could be in a shared script. What I don't understand though is if it's in a shared script, why would the palette cast member be in the local movie rather than far away one? Yeah, okay, so it's only ever used in here. It's only ever used in RTOG. So why doesn't... Alright, maybe I'm being impatient. Let's just like read each of these scripts. One of them's got to have something. Yep, that's all about going to a different scene. That's fine. How about number 5? My preload sounds important. Keep an ear out for that. Yeah. Sure thing. That's just markers and stuff. Not having much luck so far. Like something's got to be changing it. Unsatisfactory. Anyway, tell me what's in this palette while we're here. Yeah, okay, it just looks like the normal Mac palette, but they must be changing stuff. They must be changing stuff in it. How? How could they change stuff in it? Because there isn't a... As far as I'm aware, there isn't a script that's running all the ding-dang time. I think we need to do a little book learning. Macromedia director being from the 80s and 90s, all the info is in books. Mercifully, which have been scanned. Palette channel making into a puppet. I think it's this. I think it's got to be something like that, but I don't get why we don't see it in the script. That is problematic. Okay. 226. All right. This command causes the palette channel to act as a puppet. When the palette channel is a puppet, Lingo can override the palette setting in the palette channel of the score and assign palettes to the movie. The puppet palette command sets the current palette to the palette cast member specified the expression which palette. If which palette evaluates for string, because you can fade the palette by replacing speed with an integer expression. Also fade in the palette over several frames by replacing n frames with an integer expression for the number of frames. Huh. This looks like a contender. This looks like a real contender. Because it was just pulsing, right? It was just pulsing between... it was just pulsing between the Mac palette and this one. But they look the same. They look the same. I don't get it. Alright, well in ScummVM, do we do anything? That's a pertinent question. Do we change the palette when we mess with it? What was our puppet palette? Okay, so it's got a... Yeah. Oh, I've still got something open. Okay. So we have num frames and speed that are not used. With the informative skipping extra features. Was there anything in the scroll back about using that? And there's definitely like nothing in this movie which looks... Well, firstly, we don't have any other palettes. It's literally just that one. So it's gotta be... Yeah, but the thing I don't understand, right, is that maybe there's a... Like, if it was just cycling between palette 0 and palette 203, I'd get that. I really would. I'd love that. It'd be just, you know, just peachy. But I don't think that's what's happening, because if you look at, like, the colors between that and that, that and that, that and that, there's no change. Looks exactly the same, which makes me think there must be a command that lets you mess around with the colors in a palette, and it's got to be in here. It's got to be in this manual. Everything is in the manual. The palette of cast, setting the current, assigning to movies, 209. Color? Maybe I'm overthinking this. Maybe it's color. There's the color depth, the stage color, the switch color depth, the score color, the back color, the fore color, stage colors. 24. Sprite properties. Sprite must be a puppet before you can set its background color using lingo. The background color applies into one bitmap. Background color of sprite. Back color of cast. Can't just be one color that's being set. Doesn't look like it. It really doesn't look like it. Because like these shadows on the ground were being set. Maybe I'm making a mistake. Oh, there's a mat. But I mean, if it was just like a sprite, why can't I see it on the screen? How about so those two, script 210, 212, 205, and 213. All of those should appear. Oh, they shouldn't appear here. Right, we're done with that. They should appear when we mess with am I running it? Yeah, I'm running it. Sorry for all the constant tab switching. I just have very poor object permanence when it comes to things in tabs. It'll get shuffled to the back and I forget. Here. Okay. Wood. So it was getting something to do with wood. Okay, well, is Wood a cast member name? 194. Okay, wood is the text. Okay, so this code here just shows up the little text saying that, oh, this is the tree of life. That makes sense. That I'm cool with. Set the yeah, it sets a position. It sets a foreground color. I guess that means it's visible. I'm thrown because nothing here looks... Because usually if there's like a missing feature, we've got like a warning message saying, hey, you missed a feature. But I don't see anything like that in here. Wait. That's an error. Do we have any cast members with the name Face? Circle message would... Morph. Yeah, a bunch of messages. Oh, okay. Like, that's probably getting the face of the person I got rebirthed as. That's not used. Oh, it's not relevant to what we're looking for. So it's not... Okay. So on the surface, it doesn't look like there's any kind of script. And it all looks like the same palette. Oh, I really just want to test it. I really just want to test it here. How about... if I pretend there are no scripts? Scripts, be gone. Scripts? What scripts? I have a handler for something. Oh, I don't know where. I don't know what is using a handler. Oh. Okay. Well, we deleted all the scripts, so I'm more convinced than ever that it's in a script. Which, hey, makes sense to me. But like, nothing in there looked like a smoking gun. I don't understand. Oh, right, okay. I'll have another look. This time I'm gonna look at the assembly language. Before I was like looking at the script. Or the decompiled version, which can miss stuff. Yep. That's all that. Special set. What is special set? Special set must be in the shared script. Director. I think I dumped all the scripts already. No, I did not. Okay. Project arrays, dump scripts. To Unix. That's more like it. So what does special set do? Oh, okay, it just, yeah, right. It does some key binding stuff. That's less exciting than I was hoping. This is a mystery. I don't... like, there's only a finite number of things that this could be. And... like, what else could it be? Like, the only other thing that springs to mind that it could be would be like a C extension. But why would you get a C extension just to pulse a palette? That just sounds a little nuts. Okay, not gonna lie, I'm beginning to doubt myself, so let's get back at least into... let's get back into the windows. Have a look in there. Let's see if there's anything that we're missing. It may turn out to be that like the only way we can figure out what is going on is by debugging director, and truth be told, that's not going to happen tonight. That's going to be saved for another time. But Keep clicking, hoping that it'll, you know, this time it'll skip. It never does. You can't skip it. Why would you want to skip it? Yep. Oh, and I can't because it didn't save my game. Okay. Wait, but I can go to new game, which is slightly quicker. Assuming I can find the menu. Oh no. There we go. Right. Now we just want to kill ourselves quickly. Oh. It's not doing the... Maybe someone fixed the blue rendering thing. I should check that while I'm here. Can I check that while I'm here? I'll just die to begin with. Yep, then we go up through the Tree of Life. Yeah, this all. Up here, but I don't really want to check that. I want to check just quick detour. I want to go through here. If I can remember the way. Past the two mooks at the door. Golden flower. I think it was... Okay. okay, maybe someone else has patched that problem, which would be quite nice, because it was a bit annoying before. I can't remember which of the rooms had it. But they all look good. That's a dead end. Cool. Might be able to like drag a whole bunch of tickets off the queue then. Yeah, and this... Oh, can't actually go there. That's fine. Alright. So as much as it pains me to say this, I think I'm out of ideas. I really don't know what exactly is going on inside Director to make the palette all change like it is. It's got something to do with it's got something to do with this palette member here. I'm pretty sure that. So like the logical thing I can think of, right, is that there is a lingo command which lets you mess with the color contents of this. That sounds like something that should be doable. Of palette. There's like the palette of cast, the finished cast. Maybe if we have a look in like which is kind of like the source of all the things in Lingo that you're allowed to change. So we've got the entity field, the sprite, the cast, the pal. Okay. So you're allowed to change that for a bitmap, but you're not allowed to like mess with the internals of a palette. That's too much. I really want to know how they did it now. Yeah, okay. And it was definitely more than the foreground color. Or the stage color. Well. So I think we're gonna have to make a few updates. Anyway, so we'll finish off by saying, deal with the blue box there. Someone else fixed it. And investigate pelleter mystery question mark. And I think that's what we're gonna kind of wrap up today. I'll probably do a little bit more kind of research when offline and see if there's anything either I missed or worst case scenario, try and debug DOSBox to see like what part of the director code is fooling with a palette like that, but yeah, that is a puzzler, and it is not just used there in the game; it is also used in other parts. So we got to get to the bottom of it. We got to figure out what's going on. But yeah, I see. I'm looking at the streaming counter, and I've been streaming for far too long. So I am probably going to wrap up now. Thanks so much, everyone, for watching. Yeah, I will see you all real soon. You take care now.